Consider curvature in the plane. Let's take number 23. To find curvature, we need to find the norm of the tangent and then the norm of r prime. And just looking at number 23, you see that that this particular path or position vector is some kind of plane, and so it's a straight sheet, so there is no curvature, so we expect to get 0. So t here is equal to r prime divided by its norm. Now r prime of t is equal to the square root of 4 squared, which is 16, plus 2 squared, 4, so we get 20, or 2 times the square root of 5. So the tangent vector is 4 divided by 2, square root of 5, so this is 2 over the square root of 5i, minus 2 divided by 2, square root of 5, this is 1 over the square root of 5j. T prime, well, t is just a number, so we just get 0. So since the tangent derivative goes out, this implies no curvature. Number 25. R of t is equal to t I plus, just write this as t to the negative 1 j. So r prime of t is equal to I minus 1 over t squared j. And so its norm is the square root of 1 plus, we square 1 over t squared, so we get 1 over t to the 4th. You can simplify that. This is just the square root of 1 plus t to the 4th all over t squared. So the tangent vector is r prime divided by its norm, so that would give us a t squared over the square root of 1 plus t to the 4th I minus 1 over t squared divided by the square root of 1 plus t to the 4th divided by t squared. The t squares cancel out. We have left 1 over the square root of 1 plus t to the 4th j. And we know that the tangent and the normal vectors are perpendicular, so the dot products there would have to give us 0 in the combination of those coefficients. And this was one that we had seen before. So the normal vector would be, these guys would transpose, so this is 1 over the square root of 1 plus t to the 4th I plus t squared all over the square root of 1 plus t to the 4th j. Personally, I don't want to have to find the derivative of t and then its norm. So we're going to use the formula that the curvature is the dot product of the acceleration and the normal vector divided by the velocity vector, the norm of that, to be squared. And this was, the problem here was a problem from section 12.4, where we had to find the tangential components of acceleration and the normal components of acceleration. So we've seen this problem before in its setup as well. Notice here that for this tangent vector, the x direction is shooting positively. The y direction is shooting downward, and so the curvature of this guy is within the first quadrant, and so the normal vector would be x value positive, y value positive. That's why these two values are positive. So we have the normal vector for the curvature. We just need the acceleration. So a of t is the second derivative here, and if you think about r prime of t, this is I minus t to the negative 2j. So we find the second derivative on that, so that gives us a 2t to the negative 3j. So that's just 2 over t to the 3rd j. Now the velocity is r prime, and the norm of r prime is the same thing as the norm of the velocity. So we have that. So the norm of this velocity vector is this number here, the square root of 1 plus t to the 4th all over t squared. So the norm of the velocity to be squared is just 1 plus t to the 4th, excuse me, all over t to the 4th. And for this particular number, number 25, t is equal to 1. Okay. So if that be the case, this is the norm of the velocity to be squared, excuse me. So this norm of the velocity evaluated at 1 all to be squared comes out to be 2. Now the acceleration evaluated at 1, I have the acceleration here, so the acceleration at 1 is 2j. The normal vector evaluated at 1 is just 1 over the square root of 2I plus 1 over the square root of 2j. So the curvature is the dot product of the acceleration, the normal vector, divided by the norm of the velocity vector to be squared. So the acceleration here at t equal 1 is 2j. That's dot product with the normal vector 1 over the square root of 2 I plus 1 over the square root of 2j, and that's all divided by the norm of the velocity to be squared, which is just 2. So in the dot product, just the jth components would match up. So this is 2 times 1 over the square root of 2, 2 over the square root of 2, and that's divided by 2. And so this just gives us 1 over the square root of 2. So that's the curvature, if you will. You can write that as the square root of 2 over 2, doesn't matter, 1 over the square root of 2, or the square root of 2 divided by 2. Now let's look at the curvature for a curve in space. Let's take this problem here. So we need to find r prime of t. This is I plus 2tj plus 2t divided by 2, which is just t times k. The norm of r prime is the square root of 1 plus 4t squared plus t squared. So that gives us the square root of 1 plus 5t squared. Does not like my 2's for whatever reason. So the tangent vector r prime over the norm of r prime. So this is 1 over the square root of 1 plus 5t squared I plus 2t over the square root of 1 plus 5t squared j plus t all over the square root of 1 plus 5t squared k. We find this derivative. Let's write the first component as 1 plus 5t to the negative 1/2 I, and just write everything else. So now we find the derivative here. So t prime, this is negative 1/2 times 1 plus 5t. I left off my square. T squared, and this is negative 3/2 minus 1, so it becomes negative 3/2 times the derivative of the inside, that's 10t I, plus move to the jth component. The derivative of the first is 2 times the second, the square root of 1 plus 5t squared minus the first times the derivative of the second. So we get 1/2 times 1 plus 5t squared to the negative 1/2 times 10t, and that's all over the denominator squared, so that's 1 plus 5t squared j. Get the kth component. So this is plus the derivative of the numerator is 1 times the denominator, the square root of 1 plus 5t squared minus the numerator, which is t, times the derivative of the denominator, 1/2 times 1 plus 5t squared to the negative 1/2 times the derivative of the inside, so that's 10t. And that is all over the denominator squared, so we just get 1 plus 5t squared. Okay. Alright, now I'm going to clean it up, and don't want to take too much time, because if you're like me, I'm getting tired. Right? I'm getting tired of this stuff. Okay, negative 1/2 times 10t. That's a negative 5t. Back. So it's a negative 5t all over 1 plus 5t squared, and that's raised to the 3/2 power, and that's for I. Plus, let's see here, this is 2 times the square root of 1 plus 5t squared. See, 2 divided by 2 cancels out. T times t is t squared, and that's 10t squared, so minus 10t squared, and this term here just drops downstairs, and it's the square root of 1 plus 5t squared. That's over 1 plus 5t squared, and that's for J. The kth position does the same thing, so this is plus the square root of 1 plus 5t squared minus t times t is 10 t times t is t squared, and 1/2 times 10 is 5, so we get 5t squared in the numerator, 5t squared in the numerator divided by the square root of 1 plus 5t squared all over 1 plus 5t squared k. So now t prime of t is equal to, let's see, we can clean it up, negative 5t all over 1 plus 5t squared, the 3/2 power I, plus, now to combine this fraction and this fraction, we find the LCD, which is the square root of 1 plus 5t squared, multiply that radical to this guy and also to its denominator, and so we have a common denominator of the square root of 1 plus 5t squared, and then this becomes 2 times parentheses 1 plus 5t squared, which is 2 plus 10t squared minus 10t squared. It's just a 2 in the numerator. That's divided by this denominator times that denominator, which is 1 plus 5t squared to the 3/2 power. Same thing happens over here for the kth position. So we combine these two fractions by finding the least common denominator, which is the square root of 1 plus 5t squared. Multiply that LCD times this radical, and then divide it by 1 times that radical, which becomes a common denominator. So all you have in the numerator is 1 plus 5t squared minus 5t squared, which just leaves 1 over the square root of 1 plus 5t squared times 1 plus 5t squared, which is 1 plus 5t squared to the 3/2 power. And that's K. So for the curvature, we need the norm of t prime. So the norm of t prime of t is equal to, just take all the numerators, we're going to square them, add them up, take the square root of that, divide it by the common denominator, which was squared, then you took the square root of that, which just leaves itself. So the numerator is the square root of 25t squared. 2 squared is 4, plus 1 is plus 5, and that's all over 1 plus 5 t squared raised to the 3/2 power. Now you can factor out the square root of 5, and that leaves the square root of 1 plus 5t squared, and that's divided by, look at this is 1 plus 5t squared times the square root of 1 plus 5t squared. So the radicals cancel, and we have left the square root of 5 divided by 1 plus 5t squared. So it looks like we have everything for the curvature. We have the norm of t prime, and then we have the norm of r prime. That guy's way up there. So the norm of r prime was this. So it's just that radical. So the curvature is the norm of t prime of t all over the norm of r prime of t. So this is the square root of 5 over 1 plus 5t squared. That was the norm of t prime. Then the norm of r prime was the square root of 1 plus 5t squared. So that just gives us, yes, the square root of 5 all over the two denominators multiplied to each other. And so that is just 1 plus 5t squared, and that's raised to the 3/2 power. That looks good to me. Well, let's take a break. Thank you.